To create a Mirage, we first need an NBT file of a Minecraft structure. To get one, you can use the vanilla structure block to save a building as an NBT file, or use mods like Lightmatica or Create to make things easier. Make sure that the NBT file you create are located in your Minecraft schematic folder. By default, the mod will look for the schematics folder, but you can set it to a different folder over at the mod's config file. Once you place down your Mirage projector, grab yourself a book and quill. We need to tell the projector which NBT file we want it to use. Click Done and right-click on the projector with the book and quill. Give it a redstone signal at the bottom face to turn it on. Right-clicking it with a redstone torch toggles active low mode. In this state, the projector is active when the redstone signal at the bottom face is low. We can also set active low to true through book commands. If we typed in something it doesn't understand, the Mirage projector will calmly point out what we did wrong. Make sure to separate each setting with a comma and type everything right. Note that the Mirage projector remembers the last command you gave it, so make sure you pay attention to what you write down. It's a djinn inside of a magic lamp after all, so be careful with your words around it. Each file that we project is in its own Mirage world. This Mirage world has its own grid separate from the overworld. We can set our structure's position in the Mirage grid by book commands. Say we want to move it 3 blocks up from where it is by default. To mirror our Mirage, we use the mirror book command. Keep in mind this command only accepts one of the following inputs. To rotate it, we use the rotate command. This command as well only accepts one of the following inputs. We will talk about finer control over positioning in the next chapter. So far, we have only been moving the Mirage by grid. We can also mess with how the grid itself looks like by posing it. Say we want to make it look like we moved our Mirage grid off-center. We then need to use the pose move book command. Let's set it back to default for this next part. We can also scale the grid by using the book command called pose scale. Keep in mind that the origin scales with it. It gets offset from the Mirage projector. If we move the grid by 1 unit upward, it will move 2 blocks up. We can rotate it by any degrees using the pose rotate book commands. First, we need to define a pivot point in the grid. By default, it's set to the origin, but keep in mind this is not the center of your Mirage projector. In this case, the center of our Mirage projector is 0.5, 0.5, 0.5. Now that we have a pivot point, we can now rotate the grid by degrees. Let's reset the rotation back to 0 for this next part. Let's set the pivot point at the center of our block instead. Say we want to balance this block on its edge. To balance a cube, we would usually rotate it to 35.26 degrees in the z-axis first, and then 45 degrees in the x-axis. But as we can see, it's not balanced. Keep in mind that the projector rotates the x-axis first, the y-axis next, and the z-axis last, in that specific order. We want to rotate the cube 35.26 degrees first before rotating it 45 degrees in another axis. So we should instead do this. But this might not be very convenient for some cases. That's why the pose rotate command can also accept quaternions. Aside from rotating the grid, we can actually make the whole thing spin on an axis by using the pose spin commands. Like the pose rotate command, we first need to define a pivot point. Let's set it in the middle of our block. Next, we need to tell it what axis to spin on, let's say on the positive y-axis. Then we need to tell it how fast to spin in degrees per second. For this next part, I'm going to use this Mirage of an active Omni beacon. And duplicate this Mirage projector and put it above the other. As we can see, they're both spinning synchronously. We can make them spin out of sync by using the pose spin offset command. This command accepts degrees as input. So you might be thinking, why use grid positioning at all if you can just use pose positioning? It's because some blocks rely on their position in the grid. Take this enchanting table as an example. It works fine right now since the model is aligned to the actual grid. But if I try to change the pose of the grid, say move it 2 blocks to the right, our enchanting table stops working right. We moved its model to where we want it, but because the block still thinks it's back here, it stops working right. Let me reset this Mirage. To get it to work, we need to move it by grid instead. Each Mirage projector can hold more than one NBT file. Let's call them frames for now. You can specify which frames to project by using the step command. We can loop through these frames by giving a redstone pulse to any of the side faces. We can cycle in reverse by holding a redstone signal at the top face while using the side faces. We can also tell it to cycle in reverse through book commands. Using any of the grid or pose commands by themselves affects the whole list. But we can mess with the frames individually using the frames command. If we run out of space, we can always move to the next page. Let's get a fresh Mirage projector for this next part, because I'm too lazy to reset everything we just told it to do. We can also reuse the same file in multiple frames. Here I'm going to be using Gazamo's Steampunk Dragon from one of their free maps. Go check them out. I'm going to make it fly in a circle while moving up and down. We can keep on using redstone signals to step through the frames, but we can toggle on autoplay mode. In survival, you need to right-click it with a soul torch. But in creative, you can use the autoplay book command and set it to true. You can set the delay between each frame by using the delay book command. In autoplay mode, holding a redstone signal on any of the side faces pauses the animation. If you want it to only play once, type in loop false. Reactivating the Mirage projector resets the animation. It works the same way in manual mode. You can save Mirage projectors in NBT files. That means you can have mirages inside of mirages. This is off by default because it will crash your game if you try and project recursive mirages. Turn it on at your own risk over at the config file. I recommend using multiple Mirage projectors side by side instead. When a Mirage projector starts loading a Mirage for the first time, we call it the buffering stage. When it's done buffering, it can play your animation smoothly in real time, much like how YouTube loads in a video in the old days, except we are buffering 3D voxels instead of 2D pixels. The more complicated the Mirage, the longer it takes for the Mirage projector to finish buffering. Having like 60 frames with each having over 5,000 blocks will take a while to finish. The mod only ever lets 2 Mirage projectors buffer at a time. So if you start loading in 2 complicated Mirages, the next Mirage projectors you put down will not start buffering until one of the first 2 are done. The bigger and complicated the Mirage is, the laggier it gets. So that's why I made a tier list of what kind of blocks are good for creating Mirages. Head on down to the wiki to get more detail. And that's it for this video tutorial. I hope this helps, and I'll see you on the next one. Ayo ayo.